In this question, there is a piece of zinc, and that piece of zinc is placed inside of a sample of mercury. And we know lots of facts about everything. We know that for the zinc, the mass is 25 grams. We know that the initial temperature of the zinc is 120 degrees Celsius. They tell us that the specific heat capacity of zinc is 0.387 joules per gram degree Celsius. And for the mercury, they tell us that the initial temperature is 20 degrees Celsius. The specific heat capacity is 0.140 joules per gram degree Celsius. And that's it. And the question asks us, how many grams of zinc would have to be used? So that means I am solving for mass, how many grams of mercury would have to be used in order for the two temperatures to meet in the middle? So that the mass of the mercury is our big unknown. That's what we are solving for. And that key is for the temperatures to meet in the middle. So, lots of the kids that I talk to, they miss that little phrase. And so that, I think it's impossible to solve if you don't pick up on that key part of the question. Now let's just kind of think about what's going on here. The zinc starts at a higher temperature. The mercury starts off at a lower temperature. So the internal energy of that zinc is higher than the internal energy of the mercury. So heat is going to flow, or energy is going to be transferred from the zinc into the mercury. How much? All right. Well, we could maybe calculate that, but I think we can all agree that the Q that is lost by the zinc has to be equal to the Q that is gained by the mercury. Right? I mean, they're in thermal contact with one another. The zinc's going to cool down, the mercury is going to heat up, and that transfer of energy, whatever the zinc loses, that's what's going to be gained by the mercury. So, another key assumption of that. So, how I think most students would go about solving this. For mass of zinc, I know temperature initial of zinc, I know specific heat capacity of zinc. Because of a little bit of reasoning, T final, right, the middle of 20 degrees Celsius and 120 degrees Celsius would be 70 degrees Celsius. So the temp final would be 70 degrees Celsius for actually both of these guys. And then that means I have enough information to solve for Q of zinc. Q for zinc is going to equal the specific heat capacity times the mass times the change in temperature. So that means Q for zinc is going to be 0.387 joules per gram degree Celsius times 25 times negative 50, because it's dropping from 120 down to 70. So that means the Q of zinc is equal to 483.75. If you wanted to round for sig figs now, you could call it 480. I'm going to go ahead and just keep it as 483.75, and I'll round my final answer when I get this mass of zinc over here. Then we had talked earlier, the amount that was lost by the zinc, so it's negative 483.75 is the amount that is gained by the mercury. So I'm going to bring that number over here. Q for the mercury is going to be positive 483.75. And now I know the Q, I know the temperature change, and I know the specific heat capacity. I have enough information to solve for that mass. So then, if Q equals S times M times delta T, then mass is going to equal Q divided by S times delta T. So use that, plug in numbers, and 483.75 divided by 0.140 times positive 50 degrees. And we get, calculator says 69.1. I think we need to round it to 2 sig figs, because way back here the mass of mercury was just 2 sig figs. So we're going to say our final answer is 69 grams of mercury. And then, I don't know, I feel kind of duty bound to talk about the completely other way you could approach this. If this statement is true, that Q is lost by the zinc equals the Q that is gained by mercury, so that means that Q gained by the mercury equals the Q lost by the zinc times -1, right? Because that sign just got flipped from negative 483 to positive 483. And if Q is equal to S times M times delta T, I can then sub in the S, the M, the delta T for mercury, and the S, the M, the T for the zinc, and then I can cancel some stuff. So I'm going to go ahead and sub that in. So the -1 times mass of zinc times specific heat of zinc times change in temp of zinc would have to equal the mass of mercury times the specific heat of mercury times the change in temp of the mercury. And then, since the change in temp for both was 50, right? They're meeting in the middle, so there's 100 degrees that separates them. So that means delta T can cancel on each side. And actually the delta T's is where the -1 would take care of, right? Because the mercury was falling, so it's a negative delta T and a positive delta T. So I'm going to get rid of that -1 there as well, because the temp change is the same. So that gets me that mass of zinc times specific heat of zinc equals mass of mercury times specific heat of mercury. And then it becomes really simple. The mass of mercury needed just equals the mass of zinc times the specific heat of zinc divided by the specific heat of the mercury. You plug that in, boom, you're done with the question. I don't know, like 12 seconds.